When you're watching AI agent demos these days, a lot of them have the same three things in common that aren't true in production, right? The shape of it will be something like, someone opens a terminal, they type a sentence like, hey, analyze the sales data and tell me which region is underperforming. And then an agent spins up and calls a couple tools, thinks out loud, and then gives a clean answer with a chart. And the demo comments fill up with people saying analysts are finished, and it's impressive. But if we look at what the demo is actually standing on, it kind of explains why a lot of these demos don't make it to production. Because underpinning that demo was, a clean data set that was small enough to fit entirely in the context window. It was probably a really short task, only 4 or 5 steps that could be done in under a minute, right? And it only ran once. And the last one is critical because you're watching the take that worked, right? You aren't watching the takes before that where the AI agent didn't do exactly what they wanted, right? And production has none of those three things. It has dirty data where a column called region has 11 distinct values for 4 actual regions because someone typed them by hand. Production has really long context as well, where a task isn't 4 steps, it's 90, and it could be taking place over multiple hours. And by step 60, you run the risk of the agent not remembering what it decided over at step 8. And then production also has partial failures, where one API call in the middle of a chain times out, and then everything downstream is running on a hole in the data. So, and then it also has concurrency, where your agent is one of 40 things touching the warehouse at once. And then all of those have bills, where someone's going to read those bills and understand, hey, how much did all this cost us? As well as the consequences of any bad decisions there, where a wrong action isn't a bad answer on the screen that you can just reshoot. It's an email that went out, or a row that got deleted, or a customer that got charged by accident. So that's what I want to talk about today. I've seen a lot of agents put into real data workflows now, and I've watched a lot of the ways that they've come apart. And so what I want to talk about today is a lot of those reasons why, these grand visions of these AI demos, when they go to production, what happens that causes them to break down. And because you'll see an agent do something dumb, and your instinct is, oh, the model isn't good enough, and maybe the next model will fix it. But most of the time, that isn't actually the case. The actual causes that I've seen and kind of ranked in order of how often I've hit them are context, state, error handling, and cost in that order. Those will account for like 80% of what I've seen go wrong. And they're all just engineering problems, not a problem with, oh, that'll be fixed with the next model, right? They're still going to exist when the next model comes out. So that's what I want to talk about today. So for all those failure modes, I'm going to talk about, hey, what actually looks like when they happen to you, what these failures in production AI workflows look like, and then the patterns that you can use to fix it. And also at the end, I'll wrap up with kind of a handful of design decisions that will help you make sure you're designing agents that will work today and profiles of tasks that are a good fit right now versus one that an agent might not be ready for. So without further ado, let's get into it. So the first and most common failure cause that I'll see in production is missing context. And it's by the wide margin, right? So let's say you have an agent doing what should have been a boring task, right? Taking a set of order records and producing a monthly revenue summary by product line. Very straightforward. It had access to the warehouse. It could write and run SQL and read the schema, but let's say it produces a number that's 11% too high. And it's not wildly wrong, but it's wrong enough to be dangerous because 11% high looks like a good month, not a bug necessarily. And the reason was a column called order status. And in that database, order status had values you'd expect, like completed, pending, canceled, but it also has a value called completed internal, which sounds like a completed order and isn't one. It's actually an internal transfer, let's say between warehouses, that the finance team has excluded from revenues, hence forever. But no one wrote it down because, why would you write down something that everyone knows? And the agent, because it doesn't have that context, it doesn't have that kind of, real world institutional knowledge, it's just summing everything that looked completed. So any reasonable person reading that schema cold would have done the same thing, where it isn't a reasoning failure. Nothing about the model's intelligence would have saved it, but it's just a, pattern that's really underpinning this and causing this, which is an agent doesn't know your conventions, doesn't know your schema history, doesn't know why the weird column exists or which of the 6 tables with similar names is the one people use. That knowledge will live in people's heads, right? And that's where teams go wrong when they hit this, right? The instinct is, oh, we got to go reach for a better model that's going to know the difference and understand this, and intuit these difference between an internal order and an external order, and it doesn't work, right? And so what fixes it is, real world, just kind of data cleaning and data labeling. adding a note to the agent's context that said it completed internal is a warehouse transfer, not a sale, excluded from the revenue, and say, revenue is recognized on ship date, not order date. So the orders V2 table, is the source of truth, even though V3 might exist. And that's just 3 sentences, and now you have the same model, same prompt, but you're going to get a correct number. So when an agent gets something wrong, your first question shouldn't be, is the model good enough? But it should be, did I give it all the necessary information it needed, like I would give a new hire on day one, right? If you hired a competent analyst and gave them warehouse access and zero onboarding, they would make these kind of mistakes too, right? And it's be a problem with your onboarding. So one more wrinkle also that is worth knowing is that, obviously context isn't free and it isn't infinitely additive. So you don't want to dump your entire data dictionary into every call, because that's going to make the agent worse, not better, because those 3 relevant sentences are now buried in 4,000 irrelevant ones. And retrieval matters as well. So getting the right context in beats getting all the context in. And that's the part that takes real engineering and deciding, hey, what goes in and what doesn't. Now, the next thing I want to talk about is failure mode 2, which is no state between steps, right? And what I mean by that is, the agent has no durable state between different steps of its work, so on any long task, it'll just eventually lose the plot. And what this looks like in practice is very specific, and it's very recognizable once you understand the pattern. So let's say the agent is 40 steps into a 60-step job, and it's already decided back at step 9 to standardize all date fields to UTC. But then at step 41, it hits another date field and decides to leave it in local time because step 41 doesn't remember step 9. So now you've got a data set with mixed time zones and no marker telling you which is which, or it reruns a transformation it already ran in doubled rows, or it reruns the same file 4 times, right? And the cause is that the conversation history is the only memory it can have, or it has, and conversation history is a bad memory. There's 2 things that degrade at once in conversation history. The first one is the obvious one, where you run out a window and old terms get dropped or summarized, and summaries lose exactly the specific decisions you need. The second and less obvious one is that inside the window, attention over long context isn't uniform. Information sitting in the middle of long transcript is functionally less available than information at the start or the end. So the agent doesn't only forget things it dropped, it also will half forget things that are still technically there. And the fix is to stop treating the transcript as memory and externalizing state. And that means you have an agent maintain a file, right? And this is, a scratchpad, a task list, a decision log, doesn't matter. And a lot of agents will do this automatically now. And basically before it acts, it reads that file. And after it acts, it writes to it. So decisions go in with reasons attached. Completed steps get marked completed so they don't get redone. And open questions get parked there instead of getting lost. And the reason this works is that the file won't degrade. Step 41 reads the exact same 7 lines that Step 9 wrote at full fidelity, regardless of how long the transcript has gotten, so you've replaced a lossy channel with a lossless one. And this will feel like overhead, but it isn't, right? On a short task, maybe it's pure cost, but on a long task, it's going to be the difference between a job that finishes and a job that produces a subtly corrupted output. So the break even is going to be lower than you expect also, like around 10 to 15 steps. And also a written decision log is an awesome debugging artifact if you're trying to figure out why an agent made the wrong decision. So when something goes wrong at step 50, you just read the log and you can see what it decided and why, and now you can keep that as record if you ever need to go back and figure out why. Now, the third failure mode I want to talk about can be kind of a dangerous one because it, won't cost you money or time, but it will cost you trust. And the failure is, you have an agent that hits an error, doesn't stop, and then produces a plausible output from incomplete data. Silent wrongness, right? So, real use case or scenario of this is an agent was pulling from 4 sources to build a weekly report, 3 databases and 1 API, and the API call failed. Rate limited, which for that particular library came back as an empty results set instead of throwing an error. So from the agent's point of view, it just asked for the data and got back 0 rows. And not an error, but just an empty answer. And so the agent proceeded. It built the report from 3 sources instead of 4, and the report was fine. And that's the whole issue there, is that it had a title, it had sections, and the numbers looked right, but it says, hey, engagement's down slightly week over week, and there's nothing on the page that said, oh, but 1/4 of the input for this week was missing, right? It just looked at the high level like every other week's report. And obviously engagement wasn't down, but it was just a source that failed. But it failed silently. So, the alternative is if that agent had crashed, I would have seen a stack trace, spent 4 minutes on it, added a retry, and moved on. But instead, by producing a confident wrong answer that a human read and half believed, for a couple days before you figure out, oh, wait, why are our numbers permanently down? And that's, is something you really want to think about, right? Because a crash is kind of a good outcome. You want to see a loud, immediate error that tells you this is what's wrong, because silent wrongness is a horrible situation, and agents are also structurally prone to it because the whole mechanism is built to produce fluent output from whatever it has. So there's no internal alarm that fires when the inputs were thin. It'll write you a great paragraph about 4 data sources, even though it saw 3. And so what catches it, and first one, and the boring one, right, is you got to validate every input before you use them, not after. So having row count checks, did every source return more than 0 rows? Is the row count within the same band of last week's? Are the columns you expected actually present? Are the date ranges what you asked for? Just 5 lines of code for each of those checks, and that'll catch the majority of it, because the majority of it is just a source that came back empty or short. Secondly, is making the agent's tools fail loudly. And this is a design decision more in your own code that you control. So if a tool wrapper swallows an exception and returns an empty list, you built the failure mode into your own stack, and return an error object that the agent has to acknowledge in these situations and force it to. And make it something that halts the run, right? Not something that an agent can route around, because agents are very good at routing around obstacles, and that's what you don't want to happen here. And then third, you want to make sure you're also requiring provenance in the output. So make the report state which sources it used, how many rows came from each, and where they were pulled, for your benefit, because the report that tells you engagement is down tells you nothing about whether to believe it. But if it has, built from 3 of 4 configured sources and engagement API returns 0 rows, that gives you all the information you need to know to go and fix that. And the last one also has a nice property, is that it fails safe towards human attention instead of away from it. So you aren't asking the model to detect its own missing data, which it's going to be bad at. You're asking your pipeline to report a fact which it already has, which is a lot more trivial. Now, the fourth failure mode is one that your CRO or CFO is going to care about, which is cost, right? It's loops that don't terminate, running unattended on an API that bills per token. This is becoming a problem. You've seen many horror stories if you're on Twitter or LinkedIn, right? An agent's cleaning a file. Part of the job was to validate the output, and if the validation failed, fix it and validate again, which is a reasonable design, but validator had a bug where it checked for a trailing new line the writer never wrote. So validation failed every single time forever, and the agent fixed nothing because nothing was broken, and then validated again, and then failed again. And it ran for about 6 hours before anyone looked, roughly 140 iterations, and every iteration read the file into context. But the bill for that one run ended up being over $300 because, it was just doing it over and over again. But even though, $300 on its own isn't a huge catastrophe, right? Imagine that happens for, every file in a bucket, right? And you got thousands of files, right? And that means, it's going to be potentially tens, hundreds of thousands of dollars. And one is the 2 things that are, kind of annoying with this is that, one, the design that produced it is completely reasonable, right? You want a loop like that. Hey, be self-improving. The only reason it stopped at $300 is that somebody happened to look, right? And if they'd waited another couple days, it could have even been a 4-figure number. Now, what you can run now, and to make sure that you don't run into these situations, is, number one, a hard step limit on every agent run. So, a counter in your code that raises when it hits the ceiling. So prompts, aren't enforcement. If you say don't take more than 30 steps in a system prompt, it's just a preference, not a set limit. And then also token budgets per run, checked as you go, that can kill or just pause the run when it's exceeded, for you to resume if you think it needs to. Because, again, the agent shouldn't be the thing enforcing its own button or budget. And then also a repetition detector, which is the one people skip. And it's also one that would have caught my $300 run in about 90 seconds. So if the last 3 tool calls are identical to the 3 before them, then you're in a loop, and then stop. So that's a handful of lines in the code, and it's the single highest return safeguard on this list. And then monitoring, which really just means know what a run costs while it's running, not when the invoice arrives. So log tokens per step, put the running total somewhere you can see it, right? A terminal pane that shows cumulative spend for anything running unattended, which is a great thing to have visible. And then also never let an agent run unattended until you know what its worst case costs, right? Multiply the per step cost by your step limit. And if that number would ruin your week, lower the step limit until it wouldn't, and then there you have your actual budget that you should compute before the first unattended run, not after it. Now, 2 more failure modes that you can potentially run into that I actually forgot to talk about at the beginning of the video are irreversibility and evaluation. First, irreversibility, some actions can't be undone, and an agent that can take them will eventually take one. And the list is shorter than people think, right? So sending an email or a message to a human, right? Deleting or over any data, anything that moves money or changes permissions or publishing anything externally What these share is the cost of a wrong action isn't the cost of the action, it's really the cost of the cleanup, right? And the cleanup is often impossible, where you have a bad SQL query, you can rerun, but an email to 400 customers you can't unsend. So, I've watched, and you've seen online, teams spend days on damage control from a message that took agents, 2 seconds to send. And the rule I use is simple. Irreversible actions require human confirmation always, even when an agent has been right 100 times in a row. And, that's intentionally because 100 right answers is what made people remove the checkpoint, but you never want to remove that checkpoint. And the counter argument is that this destroys the point of automation. And no, right, because this is only a subset of workloads, right? Then I can also explicitly approve if I do want to send that email out. The click isn't the expensive part, right? It's the agent that's doing the 99% of the work and handing you something to approve, right? It's another 30 seconds on that workflow rather than you having to do maybe that 4 hours of writing and drafting all those emails. And there's a design pattern that makes this very easy. It lives in permissions, right? Go into your permissions file in your agent, give the agent tools that literally can't do the irreversible thing, right? A tool that creates a draft instead of one that sends, or a database connection with read access and no delete, a staging table that it can write to freely. And then it doesn't matter what the agent decides because the capabilities aren't there for it to actually hurt you. And then failure mode 6 is a bit subtler, and it's one that will quietly limit pretty much everyone. And most agents or most teams have no way to tell whether their agent is getting better or worse. Ask yourself, if you change your system prompt tomorrow, how would you know if it had helped? And for most people, the honest answer is you run it on the 2 or 3 cases, you'd see, oh, is this better? Okay, cool, it looks better. Awesome. And a gut check, saying that isn't a measurement, right? It's heavily biased towards the specific failure you fixed most recently, and ignores maybe, oh, you actually introduced 10 more failure modes that are way worse. And without evals, you'll get a particular pattern where you fix a thing that broke, something else breaks that you used to work, you fix that, first thing comes back around. So you're not improving the system, you're just moving failure modes around, and you can't see it because you're only ever looking at one case at a time. So evals are the answer. They're way less work than they sound. So an eval set is a collection of inputs with known correct outputs, run automatically, scored, and it's a test suite where the assertions are fuzzier. So start smaller than you think you should. Do 20 cases, pull them from things that have actually got wrong, which is the best source you've got because those are the failures you know are real. And then every time the agent messes up in a way that matters, right, that case goes in your set. And then, a month, you've got a set that's specific to your data and failure modes, which is worth more than any generic kind of benchmark could ever be. So for scoring, then, use exact match whenever you can get away with it, right, because it's unambiguous and free. Did it return the right number? Did it pick the right table? Did it exclude the right rows? For open-ended stuff, a model grading against a rubric works better than nothing, but try to make as many of your eval sets just, true-false as possible, because deterministic scores are the ones you can trust, when you're reading a CI failure, and then run that on every prompt change. And that's, the discipline to see how you're improving and, how you're actually making progress with your prompting. So now just to kind of summarize, I want to talk about what, actually works to solve these failure modes, and, just leave you with those so you know what you can do to fix these in production, right? So first, narrow scope over general autonomy. An agent that does one well-defined job is going to beat a general assistant that does everything at 60%. Every failure mode on this list gets worse as scope widens because scope is what generates unknown context and long chains and unexpected error states. So when I'm designing any of these right now, I keep cutting the job down until it's boringly specific, and the reliability curve rewards that very hard. And then human in the loop at irreversible steps, and only there. Don't put a human in the loop everywhere because then it's just slow software, but put it where the action can't be undone. And then have tools with restricted permissions and build the constraints into the capability, not the instructions. So if the agent should delete, don't give it delete. The prompt is a suggestion and the permission is a wall. And then have structured output where the task allows it. If the agent returns JSON against a schema, you can validate it before anything downstream touches it. And if it returns prose, you're trusting it. Schema validated output turns a class of silent wrongness into a loud parse error, which we've established is the outcome you want. And also implement suggest only before act as well. So that's really it. That's what I wanted to talk about today, just kind of where, you'll see AI agents fail in production right now and how you can avoid those exact failure states. So I hope you've enjoyed this video. I hope you have a great rest of your day. Data Guy out.